Hi everybody, so today we're going to be talking about athlete's heart. And basically what is athlete's heart? Well, athlete's heart is when there's an increase in the size of the heart due to exercising. So basically athlete's heart can be caused by two different types of exercises. So let's go ahead and take a look at this. And we're going to look at how they affect the body. So if we go like this, the first one we're going to talk about is what we call isometric exercise. So an isometric exercise, what's going to happen is this is an exercise in which there's an increase in the amount of pressure on the heart, but not really an increase in the amount of movement that occurs during the exercise, okay? So in this case, what's going to happen is, or an example would be such as weightlifting. Okay, so what happens when you do weightlifting? Well, you get a big increase in force, right? There's a big increase in force. But really, and I'm going to use this symbol right here to kind of mean like not a really big increase, right? Kind of stays the same. Really, you don't get a big increase in movement. Okay, so we're going to have a big increase in force, but not a big increase in movement, okay? So the other type of exercise that we have is what we call dynamic. So in dynamic exercise, what's going to happen is, first of all, an example of this would be something like running. And what's going to happen here is we are going to get a big increase in movement, right? Because people run for miles at a time. So we'll get a big increase in movement, but our force kind of stays the same. It'll be a mild to moderate increase, okay? And what we mean, let's talk about force now real quick. So when we say force, what's going to happen is we're going to get an increase in blood pressure, right? We're going to get an increase in blood pressure. So what's going to happen here is when people go to lift weights, and they're pushing really hard, the blood pressure can double, right? And in some cases, it's even gotten a little bit higher than that, but the blood pressure can actually double just for that short period of time while you're pushing the weight, right? However, when we run, we really don't push that much force. So we get a mild to moderate increase in blood pressure here. Another thing that's going to happen over here is we don't get an increase in the red blood cells, all right? So the amount of red blood cells we have stays about the same. Whereas over here, what's going to happen is we're going to get an increase in red blood cells. So what does that mean? Well, if I get that increase in red blood cells, in this case it's kind of, well, let's go over here. If I get an increase in red blood cells, basically now my heart has to pump more volume. And if my heart has to pump more volume, it has to increase in size, right? Here, because I have more pressure, my heart has to work harder to push that weight. I'm going to get an increase in size to make up for that pressure, right? But over here, there's no increase in volume. That has to be pushed, okay? So let's take a look now at the heart. So the first thing I'm going to do is I'm going to just draw a normal heart here. And this will be my normal. All right, that's just my normal heart that's right there. And so if we look at this, what's going to happen is this is going to be my this is going to be my right atrium, that's right here. This is going to be the right atrium. From there, the blood comes down and it goes into the right ventricle. From the right ventricle, it goes out to the lungs, and at the lungs, it gets oxygen, and then it comes back to the heart and it goes into the left atrium. Then it goes from the left atrium, it drops down into the left ventricle, and then it goes out to the body. So the left ventricle has to do the most work. So what's going to happen here? I'm getting this increase in blood pressure, right? So the heart's going to enlarge in size. So now here's the heart that we've been working out, right? It's going to enlarge in size, but because this is just having that blood pressure, just pushing the blood pressure, but not an increase in volume, this chamber that the blood comes into, that left ventricle, that's not going to increase in size. So there's no increase in the size of the chamber, the left ventricle, or there may just be a mild increase depending on the research. However, we're going to get an increase in the size of the wall, this muscle that has to push that blood. And that's what this is right here. We call this the left ventricular wall. This is the left ventricular wall, right? That's the left ventricular wall. And so now, can you see how that's bigger? Because my blood pressure is higher, It's got to pump that blood out, right? So this is the chamber that the blood comes down into. If you notice, that's staying about the same size as just a normal heart of someone who doesn't work out, okay? So because we're increasing the size of this left ventricular wall, but not the size of this chamber that the blood's in, because we don't have that increase in volume, we call this concentric hypertrophy. Hypertrophy just means there's an increase in the size of the muscle. So this is concentric hypertrophy right here. And by the way, all the chambers will increase in size, but especially what we're concerned about is this left ventricular wall here. The ventricular septum will increase in size too. So anyway, that's what's going to happen there. Now let's take a look at the runner's heart. Remember now, we have to pump more blood. So what's going to happen here? Well, the heart's going to increase in size too, right? And then what's going to happen is, if you notice now, the chambers are bigger. See the size here in comparison to there? Now this is not to scale, okay? But if you notice how much bigger that is, right? So that's because we have more volume, because we have more red blood cells we have to pump. That's going to be bigger. But the other thing is our ventricular wall is going to increase in size also, just not to the same extent that you would see when you're lifting weights. So see, we get this increase here. So this is my left ventricular wall right there, and that's increased in size, right? Let me put a little increase sign there. And then my left ventricle, the chamber where the blood is in, that's increased in size too, so we can have more blood to pump around the body. Right ventricle is going to increase in size. The two atrium are going to increase in size. So all those are going to increase in size, but like I said, we're more concerned in this right here. Okay, so now, how do they increase in size? Well, inside of here, you've got something called sarcomeres. And if you don't know what a sarcomere is basically a way a muscle contracts. So let me just draw what it looks like when it's normal. This is a normal sarcomere. And what happens is it's basically these proteins here, and I'm not going to go into all this. I do have a video on sarcomeres. But what's going to happen when the muscle contracts, these two parts here come closer together. They come closer together, right? And then the muscle contracts. As the muscle contracts, those sarcomeres come closer together, right? So what's going to happen now is in concentric hypertrophy, and by the way, I didn't tell the name of that one. I'll get to it in just a second. In concentric hypertrophy, what's going to happen is this is going to increase the size of the sarcomere. So you can see how the sarcomere keeps adding onto here. We call this in parallel. We call it a parallel pattern. And so we're going to create more to the sarcomere here, right? And that's what's going to cause this thickness. This is called parallel. Okay, this is a parallel pattern of how we make the new sarcomere. And that increases the thickness of the heart. Okay, so once again, if we come back over here, this is going to be called eccentric hypertrophy. Okay, so that's eccentric hypertrophy. And what's going to happen in this now, I'm going to draw this sarcomere up in here. So this, because this has to stretch, the sarcomere actually forms a little bit differently. So this is, say, this is our first sarcomere right here, right? This is normal, and then you start exercising. So what's going to happen here, again, these two sides squeeze together, right? What's going to happen here is you're going to keep adding on to these this way. All right, you're going to add onto these in a long pattern like this instead of that thick pattern. Now this will still increase the size of this wall here, but we keep adding onto this. And this is called in series, or a series pattern. Okay, but you can see how this is becoming longer and not necessarily thicker, right? And so, like I said, this is going to be called a series pattern, okay? So our sarcomere becomes longer. Here it becomes thicker. Here the muscle becomes thicker. The muscle becomes thicker because it's got more pressure on the heart to force that blood out while you're lifting that weight. but we really don't get an increase in the size of the chamber. Here, because we have more red blood cells, we're doing more movement, which leads to more red blood cells, which means there's more volume for the heart to pump. Here, the size of the chamber increases, so we get this increase in the sarcomeres because it has to be able to put up with that stretching of all that extra blood coming in so we can pump it out. Okay, so that's Athlete's Heart. Thank you so much for watching. If you enjoyed the video, please hit the like and subscribe button, and we will catch you next time.